All right, we are jumping into Unit 3, and we will start off today with Section 3.1. Do note, though, that this section will be broken up into 2 days. The first goal is going to be us reviewing some geometry of right triangle trigonometry. We're going to find values of trig ratios of angles, and then the next time I meet with you, we'll do the other half of Section 3.1, where we will be describing the relationship between the degree and the radian measures of a unit circle. So let's start taking a little trip back into geometry. So you'll notice that a lot of these notes are already pre-filled, but we're going to add on some information onto it. So if you have a copy of this, just follow along. Over here in our first example, we are given a right triangle, and we know that because it's depicted here with a 90-degree angle, given that that is a square there. So we're going to remind ourselves from back in geometry that that angle is a 90-degree angle. Now, given that that's a 90-degree angle, we know that across from it, the hypotenuse will always be located. So straight across from the 90-degree angle, the longest side, the hypotenuse, will always be located. So I'm going to come over here and label, I'm going to write out the whole word. Hypotenuse is the longest side of our right triangle. The legs are the sides that will always form the 90-degree angle. Okay? So notice that this side and this side form this 90-degree angle. Those will always be what we call the legs. Now that we have labeled all of these, let's talk about the Pythagorean theorem. Now, students are always very quick to answer the question when I ask, what is the Pythagorean theorem? And they are very quick to respond, a squared plus b squared equals c squared. But don't know how to explain exactly what those variables represent. So I want to suggest that you get into the habit in telling people, if you're asked what is the Pythagorean theorem, to actually say it is the sum of the squares of the legs will always result in the hypotenuse length squared. Okay? So leg squared plus leg squared will always equal the hypotenuse squared. That gives you more of an understanding of what Pythagorean theorem is. So notice that in this problem, we did not have the length of the hypotenuse. Okay, so we are using the Pythagorean theorem to find that length. So right over here, the work has been done for us. The legs were given, so they took these values and put them in for A and B. It doesn't matter which order you put them in. I want you to slow down when you guys are simplifying. A most common mistake is students doing this, 6 squared, writing 12. They multiply 6 times 2, or they multiply 8 times 2. Squared means multiply it by itself. So 6 times 6, 8 times 8. We combine the like terms to get 100. And then we square root both sides to get rid of our square, and we get a 10. Now notice that when you square root both sides, our actual answer should have been plus minus 10, but since we are talking about length, our actual answer will only be a positive 10 because we're using distance, okay? So the negative value is negligible. All right, so we have discovered now that our question mark actually is a length of 10. So I'm going to go ahead and label that there, okay? So I want you to notice here, in this example, what was given was the 2 legs, okay? I'll move my hand out in a second. And you were asked to find a hypotenuse length. I can't fit the word hypotenuse. I guess I could do this, right? Let's put this here as a leg, and I can finish it off. Okay, So in this case, you were given 2 legs and were asked to find a hypotenuse. So I want you to come down here to the bottom and notice what changes, okay? So I'm going to highlight here what was given just to make it a point, okay? So in this scenario, both legs were given. You were looking for a hypotenuse. Down here on the second example, another triangle. Again, let's label what our legs and our sides are. So if I'm standing right here looking outwards from the 90, I know that this is going to be my hypotenuse this time. And if you want, you could just write H for hypotenuse. This is going to be my leg, and this is going to be my leg. So this time, what was given to us is, here we go, was given to us a leg length and a hypotenuse length. So now you're missing a leg. So watch how they did it right here. They substituted the 1 here for the A. You could have substituted the 1 here for the B if you wanted. It does not matter. And the length of the hypotenuse was substituted for C. And then we simplified. 1 squared is 1. The square root of 5 squared is going to cancel the radical and the square out, and you're just left with plain old 5. Subtract 1 on both sides, so b squared is going to be 4. You again are square rooting both sides. And you're going to end up with b equals positive and negative 2, but you are only going to use the b equals 2. So the length of this leg over here is going to be a 2. Okay? Now, the one thing I want to draw your attention to is this. Notice that in both of these problems, when we square rooted to find the length of our missing side, we square rooted a perfect square and got 10. We square root a perfect square of 4 and got 2. What do we do when we square root a number that is not a perfect square? So I wanted to review that because you will have opportunities like that in Delta Math today. So let us pretend that our c squared had turned out to be a value of 32. And I needed to square root both sides, so c ends up being the square root of 32. Okay? Well, I am going to need you to simplify the radical as far as possible. Okay? So what do I mean by that? Well, some teachers do it using a tree format. Some teachers do it in prime factorization format. Whatever the format is, they both arrive to the same conclusion. Okay, so here's what I need you to do. So I'm going to rewrite 32 in a prime factorization format. Okay, I know 32 is the same thing as saying 8 times 4, right? Well, I'm going to rewrite my 8 in this format. 2 times 2 times 2, all right? 2 times 2 is 4, 4 times 2 is 8, and I'm going to rewrite my 4 as 2 times 2. All of these are prime numbers, all right? Now, what I know is that if I take the square root of 4, I'm going to get a 2. So I love the fact that I'm going to take these pairs right here that are 4s, because I know if I take this square root of 4 out, because this is the square root of 4, I'm going to end up with a 2. And then I'm going to put in times, and if I take this square root of 4 out, the square root of 2 times 2 is also going to be a 2. And this 2 is left inside by its lonesome self. And so I just simplify. 2 times 2 ends up being 4, square root of 2. So what I want you guys to realize is square root of 32 simplified radical form is actually 4 square root of 2. And if you were ever in doubt, check yourself, okay? Notice the values are the same, they're just written differently. Let me scoot this over because you didn't see what I wrote. So let's look at square root of 32. Square root of 32 decimal value is 5.6 or 5.7 if you want to round it to the nearest tenth. I want to make sure that 4 square root of 2 is done correctly. I better get the same answer, okay? Because all I'm doing is rewriting the problem in simplified radical form. It's the same thinking as this, you guys. If I do 2/4, I'm going to get 0.5. Isn't that the same thing as 1/2? All I'm taking is, this is a fraction that has not been simplified. This is simplified. They're both the same number, okay? So that is what I'm talking about when we're doing this. I need you to simplify this radical and rewrite it as 4 square root of 2. I'd rather you guys write 2/4 in simplified form as 1/2, okay? So it's just another cleaning up aspect of writing numbers out. Okay, so make sure you guys look out for opportunities like that in Delta Math. Let us look at now at the material that we have skipped over so far, and that's this stuff right here and this stuff down here, okay? So let's go back up here. This is our good old SOHCAHTOA stuff, and I'm going to go up here to the top. So there are two ways that you guys can do this. Some students write it out when they first get it. You know, they use pronunciation to write this out. But there are different mnemonics I wanted to introduce you guys to that some students use to help them remember this, okay? So one popular mnemonic is, which is the most popular one that I'm always hearing, is some old hippie. So I'll kind of write it down over here really small. Some old hippie caught another hippie, caught, the C, another hippie, and then this one is tripping on acid. And again, I'm not advocating drugs or anything, all right? Tripping on acid. It's just a comedic way of remembering it's called a mnemonic of remembering our SOHCAHTOA. So you use your SOH, then the CAH for caught another hippie, and then the TOA for tripping on acid. Another one that is used, and then here's another way that students display the SOHCAHTOA. They write it like this, and I'll say the other mnemonic. They said, some old horse, they write it like this, caught another horse, taking oats away. Okay, and so that's another way students write it, and they use that other mnemonic that I just told you. Okay, some old horse caught another horse, taking oats away. I guess horses like oats or something. Okay, anyhow, whether you use a mnemonic device or not, please make sure you guys know those for your future. So here's what happened over here. Let us review how we must learn how to stand at a point of reference when it comes to right triangles. All right, so hold off on this a second, and let's come over here to this blank sheet of paper that's really wrinkled, so ignore the wrinkles. I am going to draw a triangle, and it's going to be a right triangle. And I'm going to tell you that this is the 90-degree angle, okay? We know that this is a 90-degree angle and that the sum of all angles has to be 180 degrees. Therefore, this angle and this angle right here are both acute angles because the sum of both of these have to be 90 degrees to add with this one to be a total of 180. When you guys are going to calculate sine, cosine, tangent, when you're finding those ratios, you have to stand at an acute angle. You will not ever stand at the 90-degree angle. You will not stand at the right angle. So make that clear. So this is a big no-no, okay? You will only stand on one of the acute angles. So for the sake of argument, we as a class are going to stand on this angle. So I'm highlighting it in yellow because I want to draw your attention to the fact that this is where we are standing. And since we're standing here, I'm going to label it with the symbol theta. Okay, this is the symbol we call theta. All right, so we're standing at theta. Ouch. So, standing at theta, that's our point of reference. Now we need to label, because going back over here, we're using the letters O, H, and A. All right, notice all of this, OA, AH, OH. Those are the only letters we're using, opposite, adjacent, and hypotenuse. I need us to stand here and label our point, from our point of reference, label which side is opposite, which of the three sides is adjacent, which of the three sides is hypotenuse. I want you to always start with hypotenuse. Always start with hypotenuse, because it's the easiest. It's always across from the 90-degree angle. So I'm going to label this side as my hypotenuse. Okay? Now, next, you are going to find your A. And the reason I want you to find your A is because the acute angle that you are standing at will always be made up of two sides, the adjacent side and the hypotenuse side. What do I mean by that? I'm standing here. This angle in yellow is formed by two sides that come together at a point. This is the point. This side and this side make this angle. This side, we have already said, is our H side. Therefore, this side has to be our A side, because wherever we stand, we're made up of the AH. There's only one other side left over, therefore O will have to be the leftover side. So let's practice that again. Let's make another triangle in a different direction. We'll draw it really small this time. Okay, and this is not the straightest side, but you get it. All right, so again, where do we want to stand? Let's stand at the bottom angle this time. Let's do it over here. Okay, so in pink, drawing attention to where we are standing. Okay, so right here is where we're standing. That's our point of reference. Start with hypotenuse first. This is my 90-degree angle, therefore H. Okay? And then I look for adjacent. Adjacent is going to be the side that is formed with the hypotenuse where we're standing. So if I'm standing here and I know this is my hypotenuse, my other side has to be my A. Therefore, this is my O. So I hope that is helping you guys see that your AH combination will always be what forms your angle that you are standing at. Okay? It hugs the angle where you're standing at. So if I was standing here, okay, this and this would be my AH. Okay? If I was standing up here, these two would have been my AH. Okay? So make sure you guys understand that labeling. So moving away, looking at the problem we did over here, notice the theta is right over here, so let's draw attention to it. Okay, here's your theta. Okay, so you already see that this side here is your H, therefore this side right here is going to be your A. This here is already your H, the hypotenuse. Therefore, if this is your A, this has to be the O. Okay? So when you come over here to do these ratios, sine is opposite over adjacent. You're standing here at theta because that's where they're telling you to stand. Your opposite is your 8. Your hypotenuse is your 10. For cosine, caught another hippie or caught another horse, your A was next to the 6, your H is your 10, and they reduce the fraction, and so forth. Okay? You might be asking yourself, what are these right here? these are always going to be, I'm running out of space. Okay, these are the reciprocals. Can you see what I'm writing? Reciprocals. These are all the reciprocals of the given trig functions, okay? Let me tell you how to say these or pronounce them, because I don't want you pronouncing these as sin or cosine or cos. This here is pronounced as sine. Theta. COS stands for the word cosine. And TAN stands for the word tangent. So you have sine, cosine, tangent, and then the reciprocals of those are the following. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. That's how you pronounce it, okay? So, as far as reciprocals are concerned, students have no problem with these two, because once they see a T in the symbols, they know that these are reciprocals of one another. But sometimes they get confused which ones are the reciprocals of what. So here's my one suggestion that I would use, okay? I want you to notice that they all have to have an SC combination, like this, SC or a CS, okay? Here's what I mean by that. Look at the word cosine. Look at the word sine. Sine starts with the letter S. The reciprocal of sine will be the one that starts with a C. On the other hand, if you start cosine, it starts with a C. The reciprocal of the one that starts with cosine is going to be the one that starts with S, and it's a secant. So notice it's an SC or a CS combination, all right? So, how do I do these problems? Well, it's really simple. If I ask you, let me pause here a second. So if I'm asking you to find a cosecant, you have to remember that the cosecant is the reciprocal of the sine. So all you're going to do is find the sine and then remember to flip it. If I ask you to find secant, go find the cosine. Once you find it, 3 over 5, then just flip it. And the same thing goes for tangent. You're always taking the reciprocal, and that's it. No extra work. All right, so moving down here to the bottom, we have another example here, and I won't waste your time here, but we'll do some labeling. If you're standing here, we knew that this would be our H. We are standing here as our point of reference. So this is our pink angle. Therefore, this and this that form our angle have to be made up of A and H. We already established that this side is our H. Therefore, this side is our adjacent. And the leftover side has to be our O for opposite. So again, notice all they're doing is substituting. Our sine is O over H. So O over H was 2 over square root of 5 right there. Our cosine was A over H. A was 1, H is square root of 5, and tangent O over A, 2 over our A, 1. Notice to find the reciprocals, they just took 2 over square root of 5 and flipped it. 1 over square root of 5 and flipped it. 2 over 1 and flipped it.
Please release our falcons and downstairs.
So there's no extra work when it comes to taking the reciprocals, okay? Now you may question what was going on from here to here or from here to here. So I'm going to put a little asterisk here because I want to draw your attention to the fact that what I need you to do is what's called rationalize. Okay, rationalize. So what do I mean by that? Okay, what I mean by that is no radicals in the denominator. Notice right here, we have a radical in the denominator of square root of 5 and also right here. I need you to rationalize when that happens. To remind you how to do that is if you have a 2 over a square root of 5, like in this problem, we want to get rid of this, okay? The way you do that is you multiply the numerator and the denominator of the fraction you're working with by whatever that radical is in the denominator. Notice that you are actually just multiplying by the number 1. Square root of 5 over square root of 5 is just 1, so that's the identity problem. So all you're doing is multiplying straight across, and you've got 2 square root of 5 over 5. And why is it a 5? Because square root of 5 times square root of 5 is square root of 25, and the square root of 25 is merely just a 5. The same thing with this one right over here. If I have 1 over square root of 5, I needed to multiply it by square root of 5 top and bottom. 1 times square root of 5 is the square root of 5. Square root of 5 times square root of 5 is just a 5. And again, just like I showed you guys with the radical, you can prove to yourself how these are correct. Okay, look what I'm going to do here. Turn on the calculator again, clear it out. So notice here, if I type what I originally started out with, 2 divided by square root of 5, I'm going to end up with this decimal value. Well, let me write it in the rationalized form like this. So 2 square root of 5 and divide it by plain old 5. Look how the numbers are the same. So check your answers. Once you have rationalized it, check to see. Let me make sure I did it correctly and see that they are equivalent. Okay? All right, so let's wrap this up, you guys. Let's summarize everything that you have just reviewed, which is a lot of material in one little unit. So you see why I split it up. So, what do I need you to do? I need you to always stand at the designated vertex of an acute angle. Okay, remember I told you guys, you cannot stand at a 90-degree angle. The acute angles will always be formed by the adjacent and the hypotenuse. That's that AH thing I was telling you. Think of like what a relief. That was very cheesy. Sorry about that. The blank of the triangle will play the roles of either adjacent or opposite side. Those are the legs. Only legs can play the roles of adjacent or opposite. Hypotenuse will always be the longest side. And I guess that's the answer to the next one. The hypotenuse is always going to be the longest side, and it will always be across from the 90-degree angle. What is the Pythagorean theorem? I'm going to write it the way I prefer it. Leg squared plus leg squared equals to the hypotenuse squared. Okay? That is always going to be used to find the missing side of any given right triangle. Okay, you can only use that with a right triangle. So make sure you simplify by reducing fractions. Make sure you simplify by rationalizing. And I forgot to include this one in my notes. Make sure you simplifying by simplifying those radicals. Okay. Simplify radicals fully. Okay. When you do the delta math, please read the directions because sometimes they ask you guys to give the exact answer. So more than likely it's going to be radicals or whole numbers. And sometimes they're going to ask you guys to round your answers to the 10th or the 100th place or to the 1000th place. So read your directions so that you do not lose points for carelessness. Okay? All right. Thank you for tuning in, and we'll see you on our next lesson. Good night.